So now in recent videos, I wanted to put a set voltage across a component. It was a trim pot. I tried to use a Zener diode. Didn't work very well, but we could improve it. But in any case, the best improvement would be to use a voltage regulator. So there's the 7805. It's the bigger version of the 78L05. This is the smaller version. Now, the kit that I bought actually gave me WS78L05, which that is right there. And I think this is what it showed on the data sheet for stabilizing it. I actually have a 0.47 microfarad capacitor, and I'm not going to use the two capacitors just to keep things simple. But basically what this capacitor is doing is stabilizing the supply voltage and the reference voltage right there. We also have the output. So now you can see we got 15 volts at the power supply. I'm going to turn it on, and we want that number as low as possible as well. When I was using the Zener diode, we were wasting a lot more current. But in case, I have here an LED. I'll put that, the anode, the long link to the output of the voltage regulator right there. And then the resistor to ground. So at 15 volts, we would have many times the amount of current that's flowing through here. Maybe 4 times the amount of current. Because out of that 15 volts, the red LED would drop 2 volts. So we'd have like 13 volts across this resistor. But we actually have 5 volts across both of these components right here. The LED and the resistor. Because the rest of the voltage, and it's probably getting pretty hot, is being dropped by the voltage regulator. So that's what it's doing. Out of this 15 volts, 10 volts is being blocked by the voltage regulator. It's limiting how much current can go through it, kind of like a resistor, but it's actively limiting it as needed to maintain 5 volts outside to the output, I should say. So now here's the multimeter. I'm going to set it to measure voltage. We should be able to see everything. I'm going to show the supply voltage is 15 volts. We can go to the rail right there. It's slightly higher. We can also go to the 2 pins where they connect to the supply voltage. And we got 15. So top pin is in, positive supply. And then when we don't want to adjust anything, we put to the regulation pin, the center pin right there, we put ground. So it's looking at that supply voltage and outputting the 5 volts in relationship to that, out of that. So there you can see 4.99. So that's with the load. That's with about 15 milliamps of current flowing through this. The resistor is probably the least hot component. So I'll plug that first. The LED, I mean, the least hot component. I'll plug that first. The resistor probably cooled down like a little bit, but may not have been terribly hot. So yeah, we saw 4.99 when we were providing about 15 milliamps of current. And now you can see that we got basically the exact same number right there, hardly changing. It may have been a little bit better if we had a capacitor between the input and the output. But any case, or the regulation and the output. Can't remember how it goes. But any case, there you can see we got 15 volts. Now we do have a little bit of current going. So it needs some current to regulate the voltage. So it looks like probably about 2 milliamps of current approximately. So not completely energy efficient even when it's off. Definitely not energy efficient when it is on. It's not converting that voltage to a higher voltage. It's just taking that extra voltage and converting it to waste heat. Make sure and turn the meter off when you are done. So now here is the kit that I got it out of. As I said before, I'm using the 78L05. Can handle up to about 100 milliamps of current and quite not as much voltage, it looks like, as the bigger version there, the 7805. And this one says L in front of it. But in any case, the pin layout's the opposite, as you can see there, for the larger version. And here's an adjustable one. Next to it is a smaller one right there. But they don't have the pins labeled right. They're not emitter-based collectors. So there may be problems with this particular kit. But this component, as we saw, outputs 5 volts as it should. That is when we have ground right there, connected to ground. So what it's doing is you have your input voltage. That's pin 3, so that would be to the right if you're looking at the flat side, but we have the flat side to the right, making it the top pin. So we have output, pin number 1. It'd be the left pin, but since this is swiveled to the right, it's the bottom pin. Hopefully that makes sense right there. And then a lot of sheets you'll see a couple capacitors used, but this particular component, so there you can see I have ground and the positive supply, the capacitor. I do have my loop somewhere. Alright, I found my loop pretty quick, but I cut the seam just in case. And hopefully, let's get the light forward over there. You can see that this one actually says WS on top right there. Hopefully you can see that. And then 78L05. So I believe this may be built to different standard than other brands of the 78L05. So I'm not sure of the quality of the components of this kit. Just to mention that at this moment. But yeah, we're going to end it there. So, in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.